You can still write it because you know I'll talk. Okay, so today what we're going to do is we're going to continue our look at those linear functions, those linear relationships. Remember, we call them linear because if you plot those dots, they all make a what kind of line? A straight line, right? Okay, it's a slash. All right, slope, gradient. All right, so today we're going to talk a little bit more about some linear relationships because we're going to talk a little bit about what's called slope or gradient. The words mean exactly the same thing. So the two words. So you can call it a slope or you can call it the gradient. The book will start off calling it slope and then they move to gradient. I've always used the word slope, so I'll use slope, but your test materials and other things will use the word gradient. So I need you to know that they both mean the same thing. Have you ever heard the word slope before?
Nope. Yes.
What happens when something slopes? Sure, it either goes what? Go ahead.
It either goes down.
Down or?
Slowly, like in a pool. It goes down and that's a slope.
Okay.
And then it's going up the pool and that's like an upper slope.
Sure. So the classic Wellington example is?
I literally live on
a hill. You bet. There's hills, right? The hills have slope.
Every time there's wind, that's
Come on. Okay. So we're going to talk a little bit about slope or gradient. Now I want to do a little example for a moment. Think about if you have a set of stairs. Okay? Now, if you're walking up the stairs, do you move forward first or do you lift your foot first?
Lift your foot first.
Right. You can't move forward because you'd hit that next step, wouldn't you? Okay? So when you're walking upstairs, you first lift your foot, right? And then you move forward. Make sense? So, if you think of stairs are just another way of climbing a line, right? But again, keep that idea in mind that you have to raise your foot first and then you move it forward, right? Now, going down the stairs, okay, right? We go down the stairs the same way. Yes?
Are you married?
Shh. Now, today we're going to talk a little bit about slope, right? And talk about how it works in relations to lines. But keep that stair metaphor in mind as we go. So I'm going to define slope or gradient for you. Slope is defined as in a couple of different ways. The most common way we think of slope is using the phrase rise over run. Okay? Now let's think about what that means. Okay? So rise means you're going what?
Up.
But you could also have a negative rise, which means you're going what? Down. So a rise is how much we go up or down. Okay? Now, our run, right? Run means you're going straight across, right? So you're going horizontally. So that means how far you're moving either right or left. So it's rise over what? Run. And we talked yesterday about the Cartesian plane. Remember, we had our two axes. This was the x, that was the y, right? Which one tells you to move up or down?
The Y.
The y's, right? And which one tells you to move right or left?
X.
X's. So what we're talking about here is
Last time that you can change the variable.
you can, but traditionally when you're just talking about a generic one, we use x and y. Okay. So what we're talking about here is our y over our x. So it's backwards, right, when you're talking about slope. Because normally if we're plotting a point, we would never do anything but what first? The right or left is always first, right? But we're not talking about plotting a point here. We're talking about the slope. So that's going to be rise or run. So that's going to be up or down first. And then, so just like you're walking upstairs. Okay? All right. So let's think about then how we can find the slope using what's called the counting method. We're going to look at a couple of different ways of finding the slope. And the counting method, so one of the things that you need to make sure you're doing is you have to know what information you have, right? Okay. If you have someone's phone number, can you call them?
Yeah.
Sure. But if you have only their email, you can email them, right? It's different, but you're still connecting to that person. But you're still connecting to that person, right? Okay. Now, what if you did have both?
Then you can call them, you can text them, and you can email
So
them.
you can just make a choice. You have more options with more. Hold on. If the more information you have, the more options you have, right? So the same thing is true with graphs, but you've got to be careful and know which piece of information that you have. So the counting method is when you have the graph. So it's for finding the slope. So it's finding the slope using the counting method, but I can only use the counting method when I have what? The graph. I need that picture in front of me in order to use the counting method. And all we're going to do for the counting method is first find any two intersections. Remember when we looked at the graph yesterday, of course the technology wasn't working right, but remember that they have, the typical graph has those little grid lines on it, right? So when I say an intersection, I mean any place on that graph where the line crosses one of those little intersections of the grid lines. Okay? Then from one point, you're simply going to count rise over run to the next point. Okay? So from one point, you'll just count rise over run to the next point. And so that's why it's called the counting method. All you're literally doing is just simply counting. And you really only have to count once, although for effect, they're going to give you, they're going to let you count more than one time, but it really only count, you only have to count one time. Yes? Pardon?
Does that say
From one point.
Oh.
Sorry. Okay? So from one point, you're going to choose 2 points, right? And you're just going to count from one point to the other, making sure you're counting rise over what? Run. Okay. So let's look at some examples. So we're going to go to Education Perfect and look at some examples, and we're going to talk a little bit about what slope is. So here we go. All right. So we're just going to go through a little bit of their discussion so that you can see the language they use and how they put things on, because that's where you're going to be doing your work, right? So in this lesson, you're going to learn about slopes and gradients. What do we already know? That slope and gradient are the what? Same thing. Excellent. Good. The slope of the line simply tells how steep it is, right? How much it goes up or how much it goes down. And if you look, you can have very steep lines or lines that are not so steep, right? Okay. We can describe the steepness by looking how much y changes as x increases, and they say by 1. It doesn't always have to be by 1. It can be more, okay? But look at what we have here. We have our graph, right? And so they're just picked 2 points, but I disagree with their method a little bit because it gives you the impression that you do the x first, but slope is always the y first, the up first. So instead of counting like they've done, what I want you to do is Just go from any point. And again, it doesn't matter what point. Let me just get a different color here. So let's say we're going to go from here to there. Notice those are nice, easy points to use because that's where the line hits the grid lines, right?
It's a trend line.
So make sure that you look at where the lines hit the grid lines. So from this point, we'll just call it A, to this point B, we're going to count first rise, then what? Run. So to get from that point, I have to go up here and then to the right there. Do you agree? So how many values did I go up to get to that point? 2. So I know my rise is 2. And then I have to go to the right 1. Guys, I have to go to the right 1. So that means my run is what? 1. And 2 over 1 simplifies. What's 2 over 1? Just plain old 2. So that tells me that the slope of this line is 2. Or you could say the gradient is 2, whichever you prefer. Okay? That's all there is to it. You're going to be counting from one point to another point. Can you handle counting?
No.
No? Okay, well, guess what? You're going to get to learn.
Oh, no.
Okay, so here we go. That's the same graph. So here's a different graph. Okay? Again, it doesn't matter what points. So I'm going to select different points than they use. But make sure that those points, wherever points you select to count from, one of them is both of them need to be where the line is crossing the grid lines, right? So there's a point and there's a point, right? So all I need to do is go there to there. Do you agree? So that means I'm going to go up how many? And to the right how many? 1. So that's 1 over 1, which is just plain old what? 1. So the gradient or slope of this line is 1. Every time you go up 1, you go to the right 1. Looks good so far?
Yeah.
Good. Bored? Okay. Now, you'll get over it. Okay.
I know I will.
Next thing we're going to look at this one. We're still going to use the counting method because we have the graph. So let's just choose 2 points. Let's choose this point and this point because they're where the line crosses the grid lines, right? This time, in order to get from this point to this point, I'm not going up, but what? Down. Well, down on a graph indicates what kind of number? Negative, you bet.
Right?
That's exactly right. So down 1 is negative 1. Okay? So what if I went down 3? Negative 3, right? And then I'm going to go to the right 1. Right is a positive number, right? So that's just a positive 1. And then I simplify that fraction. What is a negative 1 divided by a positive 1 going to make?
I have a question.
Okay? Well,
-1.
negative 1, exactly. Remember, a negative divided by a positive always makes a negative. Yes?
How come you didn't just go up and across his head?
Well, you can, actually. She was asking how come I didn't go up and across, and you definitely could. Say I went from this point to this point. That's up 1, but instead of right 1, I went what? Left. And what kind of number is a left in a graph? A minus 1. And 1 divided by negative 1 is negative 1. So no matter where you count, as long as you're doing it as rise over run, doesn't matter which side, if you count up and left or down and right, you're still going to get the right number. Looks good? Okay. Now, if a line is headed up, so you're going uphill, that always indicates a positive slope. If a line is going down, that always tells you that your slope is negative. So you're always going to know whether you got the right sign by looking at your original line. Is it sloping up? Therefore, it's what? Positive. Down, it's what? Negative. Okay? Good deal.
I knew that.
All right, so you can always have a check. Here we go. So this graph shows Noah's distance from home over time. Okay. Describe the slope of the graph. Ready? Go. Tell me what the slope is.
Positive.
No, don't worry about that. Just do it first, and then I'll ask you questions. You figure it out.
It's going
Shh. Talk when I ask you. Okay. Everybody got the slope? Okay. All right.
up. Yes.
Then, all together, just tell me, is this slope positive or negative? Positive, because the line is going up. Excellent. Now, if I count from one point to another point to find the slope, what do I get in this particular case? What is the rise?
The rise is 2.
The rise is 2,
And then
and the run is what?
1.
1. And again, it doesn't matter which points you choose as long as the line is crossing some grid lines. Going from there to there, I went up 2 and to the right 1, which means both positives, which simplifies to give me a slope or a gradient of 2. Okay? It's good. Now, you do need to, however, tell me that it is the slope. And remember that I told you could use any letter you want to be a variable?
Yes.
But then I told you, however, as we move forward, you're going to find that some letters are reserved for special uses.
Yes, like X and Y.
Okay? So, this is one of them. Slope is always represented by the same letter all the time. It's the letter M.
Why not S?
I don't know. You want to look it up? You can. I don't know. But anyway, it's always the letter M. So anytime you see the letter M, you always think slope, or what's the other word for it?
Gradient.
Gradient. There you go. So you need to label these when you're putting these together. So know that M always stands for what? Slope. Yes, ma'am.
I still so close.
Shh, guys, I can't hear your question.
I still don't understand how to calculate this one.
Okay. To calculate it, all you're doing is counting, right? So just pick any points. Okay. Any points
Do they
as
have to be on the corner of a square?
exactly. They have to be at one of the intersections of the grid line. So like I could go from here, I could even go from there to there, and I would still get the slope as long as it's on the grid line. So let's just count out those. Remember, you count what? What's first? Rise first and then run.
Run.
So we're going to go from up here and then to the right there. Well, to get from here to there, I have to go up how many units? 1, 2, 3, 4 units, right? And to get from here to there, I have to go to the right 2 units, right? So that gives me my rise over run, but I couldn't leave it as 4 over 2 because that's wrong, isn't it? It's 4 over 2 means 4 divided by 2, which is what?
Which is 2.
So is that the same answer I got a while ago?
Yeah.
You bet. So you can always get it from any 2 points. So it doesn't matter. As long as you reduce the fraction, then you could use any 2 points that you find that are convenient for you, right? So any 2 points. But you're exactly right. They do have to be at the intersection of those grid lines. Okay? Okay? And it doesn't matter. Now be careful. As we step 1 along the x-axis, we move up or down in this case. Up on the y-axis. How many steps?
10.
So it doesn't matter which one you choose. Just choose some
Wait, no.
intersection points. Oh, shoot. I don't want that. Okay. So say we have a point here, and then we have a point there, right? Doesn't really matter as long as they're crossing the grid lines. We go up how many? 3, right? So we're going 3 steps. Up the x-axis. Make sense? So, pretty good one to end the day with. So let's see what else they do. So now they just start calling it the gradient. Does that matter? Absolutely not. Okay? But they do tell you some interesting facts here. The larger the gradient, the steeper the line. So if you have a gradient of 1, that's very slow and soft slope, right? But if I have a gradient of 5, that's very steep. Yeah? So, okay. Again, gradient is the same thing as slope, so it can be found exactly the same way using the counting method. Okay? When you're moving down, what kind of gradient are you going to get? Positive or negative?
Negative.
Negative. Good. When you're moving up, you're going to get a
Positive.
positive. Good. Okay. All right. Well, then, that concludes the lesson. Let's do some work together.